Good morning, all of you. So today I will discuss about mechanical properties of fluids in that session 4. In that mainly we'll start discussing about pressure difference when the liquid is accelerating horizontal direction. The liquid is accelerating in horizontal direction, then how the pressure difference we'll see. Are you able to see the screen? Mechanical properties of fluid session 4. Are you able to see the screen? Can you confirm once fastly?
Yes, sir.
Yes, okay. I'm keeping the heading. Are you able to see? Pressure difference.
Yes, sir.
Okay, thank you. Pressure difference when liquid is accelerating, when a fluid or liquid is accelerating horizontally. Accelerating horizontally. Okay, horizontal direction or horizontally. Okay, in that case, you will see. So let us consider a container of liquid. You can take like this. Okay, in that you can draw the liquid value. So I'm drawing here with the blue color. Here it is accelerating horizontally. So let us say this acceleration, let us say some A. Okay. Then if it is accelerating horizontally, how the liquid will be? Suppose if it is filled partially, like this, up to this it is filled. If the liquid level is like this, no. The liquid level you can see, if it is accelerating, it will be like this. The liquid level changes like this. Are you able to observe this point? So it will go back certain liquid because of the pseudo force acting. So it is forming like inclined surface of the liquid. So this is the interesting point you have to understand. Okay. Then if it is forming inclined surface, let us consider an imaginary cylindrical column of liquid horizontal. I will take now. Imaginary cylindrical column like this. Actually, in the pressure concept, what we discussed, horizontal level, the pressure will be same at the given horizontal level from the free surface. Only vertically the pressure is changing. Yes or no? Vertically pressure is changing, horizontal levels the pressure will be same. But here in this case, because of this acceleration, you can observe the pressures you can see, let us say here this side, point P, the pressure at this point P is P1. This is the point Q, the face of this cylindrical column, cylindrical horizontal level, cylindrical row. At point Q, pressure is P2. Actually, you can observe this is the open surface or free surface. Then outside we can have atmospheric pressure P0 already. Okay, up to this. But this point P, you can observe this from this point, the height of this point P. Okay, this is let us say H1. So this point Q from this open surface, let us say H2 height. Your heights are different while accelerating horizontally. Okay, so the heights are changing. This height is H1. This height is H2. Are you clear this point? Right. Now, the horizontal level, you can draw one more horizontal level between the free surface points of this point P, point Q. This is the horizontal level. Then there is a height difference also again you can see between them, that is H1 minus H2. Yeah, this height difference, what is that? H1 minus H2. What is this? This is the difference. That is equal, let us say some H. Okay. This. So let us three endpoints, you can say P, Q, let us say this point is R, this point is S. Okay, this horizontal level point, let us say T, intersection point, P, Q, R, S, T. Okay, now you can observe this is making a triangle, right angle triangle. Are you able to follow it? It will form RS again, right angle triangle. Then it form an angle. It makes an angle theta here because of this is a horizontal accelerated. So this is about understanding about this diagram. Now you can calculate pressure difference at the two horizontal level points. Okay, actually up to previous discussion vertically we observed pressure difference. Now in this case we can observe the pressure difference at two horizontal level points. Then what is the pressure at point P, P1, pressure at point P, pressure at P, point P, that is P1. P1 is equal to P naught atmospheric pressure plus, let us say density of this fluid is rho. Okay, rho G. What is the height of this depth of this liquid from the free surface? H1 depth. Rho G H1. Are you clear this point? P1 is equal to P naught plus rho G H1. Yes or no? Yes. Then pressure at point Q, you can tell me. Pressure at point Q, P2 is equal to E naught plus rho G H2. Rho G H2. Okay. So now the liquid is moving horizontally. Let us say this horizontal, this cylindrical liquid. Let us say mass of the cylindrical liquid is m. Then what is the force acting at point P? Because it is moving towards right, then force definitely it will act towards right. You can say let us say F1 here force. Here force acting at point Q oppositely by this liquid is F2. Okay, now what is F1 value? F1 is equal to pressure P1. Let us say area of cross section of this cylindrical imaginary one is A, then F1 is equal to P1 into A. Similarly, force acting at point Q is F2, then F2 is equal to P2 into A. Okay. Now, because of the liquid is moving horizontally, then definitely this horizontal imaginary cylindrical liquid also moving horizontally, then definitely there is a net force acting on that to move horizontally. The net force is equal to F1 minus F2. Okay, net force. According to Newton's second law, net force F1 minus F2 is equal to MA. Net force F1 minus F2 is equal to MA. Okay, then what is F1? You can substitute P1 into A minus, what is F2? P2 into A. P1 into A minus P2 into A is equal to M into small a. Small a is the acceleration. What is M value? M is equal to density into volume. Density rho, I said already, volume V. Then I can write density rho into volume V, you can write as, let us say, let L be the length of the cylindrical liquid. Then L be the length, then volume, you can write area of cross section into L, rho AL. Then I can write MA is rho AL into small a. Rho capital A L into small a. That is P1A minus P2A equal to rho AL into small a. Okay. Now capital A is common in both sides. Then you can remove that. Then pressure difference you can write between the 2 points at a same horizontal level is P1 minus P2 is equal to rho LA. Rho LA. P1 minus P2 is equal to rho LA. Okay. This is one equation, the pressure difference value. Up to this, are you understood all of you? Let us say equation 1. Now we can substitute P1 and P2 values here. We already written P1 is equal to P naught plus rho g H1, P2 is equal to P naught plus rho g H2. Then you can substitute P naught plus rho g H1 minus P naught plus rho g H2 is equal to rho LA is equal to rho LA. Now I can substitute here. Here P naught cancel. Okay, then you can write rho g H1. Here I can write right side. Rho g H1 minus rho g H2. Rho g H2 is equal to rho LA. Here rho is common both sides. Rho cancel. Then G is common. Then G into H1 minus H2 is equal to L into A. From this you can write H1 minus H2 by L is equal to A by G. H1 minus H2 by L is equal to A by G. This is equation number 2. Okay. H1 minus H2 by L is equal to A by G. Now you can see the diagram once again. From the diagram you can observe there is a triangle RTS. Are you observed the triangle RTS, right angle triangle? From the right angle triangle RTS, what you can write? I am writing below the diagram. From the triangle RTS, right angle triangle. From the triangle RTS, you can see here tan theta is equal to opposite side H1 minus H2 divided by adjacent side is L. If this is L means this also L. Then from the right angle triangle RTS, tan theta is equal to opposite side H. H means H1 minus H2 by adjacent side L. Or observe this equation, tan theta is equal to H1 minus H2 by L. This is equation number 3. Then you can observe equation 2 and 3. From equations 2 and 3, what you can understood? Let us say this is equation number 3. From equations 2 and 3, you can write A by G is equal to tan theta. From equation 2 and 3, what you can write? A by G is equal to tan theta. Where theta is the angle made by the inclination. That means an inclined plane from the horizontal. Then A acceleration is equal to G tan theta. A is equal to G tan theta. This equation we have calculated in mechanics. Newton's laws. Have you remember anybody? A is equal to G tan theta. Acceleration A is equal to G tan theta. If a body is inclined with a mass m is falling on inclined surface, then acceleration we have calculated. That means the inclined plane is moving with an acceleration, then the pseudo force we have calculated. In that case, we have calculated acceleration A value. So in the same case, the liquid, you can see liquid also moving horizontally with an acceleration A. In that case, that acceleration in terms of G, you can see A is equal to G tan theta. Okay. So this is one important relation. Actually, our calculation is pressure difference when the liquid is accelerating horizontally. Then the pressure difference we said P1 minus P2 is equal to rho LA. That is equation number 1. And the height difference also can calculate. So left side height is greater than that of right side height. That is H1 is greater than H2. Then H1 minus H2 is H1 minus H2 divided by L is equal to we have written A by G. Okay. So that is equal to tan theta. I hope all of you understood this. Yes. Okay. Right. Thank you. Next we'll go for. Before going to next topic, there is a part of classroom activity. Let us see how to handle the problems. Are you able to see the screen? Class activity NCRT. Yes.
Yes, sir.
Right. So in that first question, you can see here. First question. That the two thigh bones, femurs, each cross-sectional area at 10 centimeters square, support the upper part of a human body of mass 40 kg. There are two thigh bones, femurs, each cross-sectional area 10 centimeters square, support the upper part of human body. Total mass is 40 kg. Estimate the average pressure sustained by the femurs. Estimate the average pressure sustained by the femurs. That means you can imagine the human like this, in that upper body like this. Okay, here there are two bones like this. Here the thigh bones. These are the two bones. Then total mass you can imagine like total upper body like a mass like this of 40 kg. That is balanced by two supports. Those are two bones. Okay, like this you can imagine. Then the pressure at each bone, cross-sectional area, pressure sustained by the femurs or the bones. So that area of cross-section of this you can imagine like a column of rods like that, these bones. Then in that case, this weight is acting vertically downwards, 40 G. That is balanced by these two bones. The normally pressure P is equal to net force F by area of cross section, F by A. So that how much area of cross section it is building upon. So each bone has certain area of cross section, like this you can imagine. Then it is two bones is there now. Then 2 into total area. 2 times it is acting. Okay. Suppose only one leg means only one area you can take. Here two legs means two bones you should take. Then first F is equal to how much? mg. M is how much? 40 kg. Into G, let us say 9.8, let us say 10 approximately. 10 kg per meter square. Then force is 400 newtons. How much force? 400 newtons. Then area how much? So each bone cross section area 10 centimeters square. Then total area A dash is equal to 2A. Then you can write P is equal to F by 2A in this case. Or P is equal to F by A dash. Then A dash is equal to 2A you can write. Okay. Then what is 2A value? You can calculate 2 into A value. See here, each area is 10 centimeters. Yes. Each area is 10 centimeters. But Nithalan, if any business you can discuss, otherwise mute. So each area is 10 centimeters square. You can convert to meter square, 10 centimeters square. So 2 into 10, 20 into centimeter means 1 centimeter is 10 power of minus 2 meter. 10 power of minus 2 meter square. Then 20 into 10 power of minus 4 meter square. Okay, then you can write now P is equal to F by A dash. F is 400 by A dash. 20 into 10 power of minus 4. Are you clear this? So then this 0, 0 cancel. This 40 by 2, 20 into 10 power of minus 4 will become plus 4. 20 into 10 power of plus 4. That is 2 into 10 power of 5 Newton per meter square. So that is Pascal. Are you clear this?
Yes, sir.
Yes, that is the average pressure sustained by the two femurs. If you take two femurs, this is the value. So next, what is the pressure? And if you want one femur means, so that means this is a total force 400 newtons total force. That is utilizing two femurs. Then you can divide for each one. Okay, right. Next, what is the pressure on his femur 10 meters below the surface of a lake? What is the pressure on his femur 10 meters below the surface of the lake? So I said already pressure with the depth. What is the formula? I'm writing right side. P is equal to P naught plus rho GH. Are you clear this equation? P is equal to P naught plus rho GH. Yes or no? What is P naught atmospheric pressure? P naught is equal to 1.013 into 10 power 5 10 power 5 pascals. Okay, suppose you have a container like this. That means you can imagine the swimmer also inside the water, means outside atmospheric pressure will be there, P naught. Okay, then total pressure P is equal to P naught plus rho g h. Then you can write the pressure on a swimmer 10 meters below the surface of the lake, means P is equal to P naught, that means 1.013 into 10 power 5 plus rho g h. Rho means, so pressure means swimmer means inside the water. Density of water rho is equal to, I remember, anybody tell me density of water? I said already. Density of water is equal to 1 gram per cubic centimeter. 1 gram per
0.98.
cubic centimeter, that is 10 power 3 kg per meter cube. 1 gram per cubic centimeter or 10 power 3 kg per meter cube. Then you can write G, acceleration due to gravity, let us say 9.8, let us say 10 approximately. And H is how much? 10 meter. Then you substitute rho g h. Rho is 10 power 3 in terms of SI unit into G10 into depth 10. So total 10 power 5. So 1.013 into 10 power 5 plus 10 power 5. So 10 power 5 common, 1.013 plus 1 into 10 power 5. So that is the 2.013, 10 power 5. Okay, 2.013 10 power 5 pascals. Are you clear this? Pressure on a swimmer 10 meters below the surface of a lake. Understood? Yes.
Yes, sir.
Okay, this is including atmospheric pressure. If you remove atmospheric pressure, then only 10 power 5 pascals. Okay, so this is about classroom activity that is given in the content. You can check, and then we have home activity is there that we have to do. Okay, right. Next we'll go for one more topic, Pascal's law. Pascal's law, this important law, Pascal's law. Pascal's law. Okay, so Pascal's law, what you have to understood, I'll tell you. Suppose you have a container, first you can take a closed container. And take container like this. In that there is a fluid. Or a liquid you can take. So the liquid or fluid are there. Now up to top, up to certain level you can take. After that there is a piston you can keep here above the free surface of the liquid. There is a piston. This is the piston you can imagine. Now above the piston there is a force acting like this vertically downwards. Okay, the piston, you have a handler now for piston, suppose. With respect to handler there is a force acting like this. Okay, in that case what happened? So this is like a open end, you can imagine. Open end. On open end there is a piston. Okay. So here the force acting now, in that case vertically downwards, first here. Okay. Now in that case, the piston is pressing all the liquid. Suppose outside pressure we have P naught. Suppose at a point P you can take here. Suppose at a point A or at a point Q. This is the point Q here. At this point Q, how the pressure? Okay, you can see. Suppose, then what you can write normally, P is equal to pressure at a point Q at a depth H, P naught plus rho G H, where H is the depth. Okay, P is equal to P naught plus rho G H. Okay, that is now You are applying this piston pressure downside. Then what happened? This pressure acting on this fluid. Suppose you can say, this pressure, what happened again? That means whatever force acting on this fluid molecules here, these molecules will try to come down slowly, but there is a compression is happening. Then immediately this compression will be reacted like this on the walls of the container by the liquid column. It will make like this. For action, there is a reaction on the walls of the container. Then that we can say here. Suppose you can take a change in pressure P naught, delta P naught. Change in pressure is P, delta P is equal to delta P naught plus delta of rho GH. Okay, delta of rho GH. So there is a small change in H, there is no big change in H, then delta H is 0. Let us say delta rho will not be 0, delta G will not be 0. Then delta P is equal to delta P naught. The change in height is very, very small, very negligible, very small depth it is change. That means the piston is moved. Then in that case, delta H will be 0, then plus 0. Then delta P is equal to delta P naught. So this is one condition. That means we have to change in pressure is same, constant. Delta P is equal to delta P naught. That means P is equal to constant. P is equal to constant. That means you can write F by A is equal to constant. P means F by A, no? F by A is equal to constant. From this you can write F1 by A1 is equal to F2 by A2. F1 by A1 is equal to F2 by A2. Suppose if you take two area of cross section and two forces. Application I am talking. Now, once you can understand this, now I can define Pascal's law now. If any small change in pressure applied on a liquid column, that change in pressure will be distributed to all the levels of the container. That means to the surface of the container. Okay, that means if you can make a change in pressure one side, let us say by using piston you are making, that is the external applied force. Because of that, there is a force applied that is trying to move the column of the liquid in such a scenario. Okay, the external pressure is applied to an enclosed fluid. So this external pressure will be transmitted every point of the liquid. The external pressure change will be transmitted to every point of the liquid without undiminished. Without undiminished. This is known as Pascal's law. Okay, this by using this piston, this pressure is trying to increasing, so that whatever applied pressure or change in pressure will be transmitted to the each and every part of the fluid. It's a transmitted pressure each and every part of the fluid without undiminishing. Without undiminishing. Okay, that I can write as a statement. Okay, once again, if an external pressure is applied, to an enclosed fluid, or liquid. If an external pressure is applied to an enclosed fluid or liquid, it is transmitted. It is transmitted to every point of fluid with every point of fluid. It is transmitted to every point of fluid undiminished. That means without diminished. That is undiminished. Okay, undiminished means without diminishing, it will be transmitted. So this is the step. This is called Pascal's law. This is very, very important. Based on this Pascal's law, there are so many applications nowadays, like hydraulic lift, hydraulic press, hydraulic brakes, hydraulic jack. Okay, this proclines heavy vehicles, proclines. Okay, all the machines. earth movers, all the machines will work on this Pascal's law only. Are you clear this statement? If an external pressure is applied to an enclosed fluid, it is transmitted to each and every point of a fluid undiminished. That means without diminishing that change in pressure, it will be distributed to each and every part of the container. That's why you are applied here with the piston one side, the pressing, that will be distributed to all the container surfaces. That means walls of the container. Okay, it will be redistributed to walls of the container. Are you clear this point, all of you? Yes. And now this how will be used in applications. In one application, I'll explain. Okay. The applications I can write here. Applications of this Pascal's law. One is hydraulic press or hydraulic lift. Hydraulic pressing or hydraulic lifting. Second is hydraulic brakes. Third is hydraulic jack. Hydraulic brakes. Have you observed any time hydraulic brakes of the vehicles or air brakes? Hydraulic jack. Okay, so these are the applications. Or hydraulic lift also you can say. Press or lift. Press or lift. Okay, so this is one thing. So hydraulic lift I will explain now. Okay, you can see here hydraulic lift. Suppose you can take this diagram, a small hydraulic lift diagram. Suppose this is a small tube left side, interconnected. Right side some larger area, bigger area tube. Both are same level, you can imagine. That will be connected to one horizontal tube for the liquid movement. Okay, so this and all interconnected. Inside this is the liquid is there. This is interconnected, you can imagine all the entire system. Okay, here there is a piston. Here one piston, which is connected to liquid. Here one piston, there is a connected to liquid. Okay, this area of cross section, let us say A1. This area of cross section, let us say A2. So A1 is smaller than A2. Let us say A1 is less than A2, area of cross section. A1 is less than A2. Then now you can apply force F1 here. Okay, here you can put some heavy weight lift now. So you can put a car here, suppose, to lift a car. So here force applying downside, then this force here this side apply force F2 upside by compressing this liquid because of the pressure change. Then what is the equation I said according to Pascal's law? F1 by A1 is equal to F2 by A2. Okay, then if F1 how much applied, then F2 how much will come. Suppose area A1, let us say a small area like area A1 is 1 meter square area of cross section. A1 is 1 meter square. Area A2 is let us say 10 meter square area of cross section. Okay. Then what is the F2 value? If suppose if F1 I applied, F1 is equal to 1 Newton. Then F2 is equal to A2 by A1 into F1. That is A2 10 by 1 into F1 1. That is 10 Newton. That means if you apply 1 Newton this side, then this side it will come in 10 Newton. This is the application. Okay. So this is the time up. Thank you, Ananda. So this is already recorded. Don't worry, you can see once again. Thank you. Have a nice day.
Thank you, sir.
Thank you. Right.